Hello, I'm going to review Chapter 8, talking about just basic statistics. We're going to calculate the mean of some numbers. We're going to do basically what's on this through these 5 questions that are asked here. We're going to create a dot plot, a histogram, and a box and whisker plot. And then we're going to calculate the mean in the interquartile range of the data. We're going to determine the upper and lower fence of the data, which will help us identify what the outliers are, if there are any. And then for numbers 4 and 5, it says we're going to remove the outliers and then calculate the mean to see what happens to the mean and how it's affected by the outliers. And then lastly, we're going to kind of modify our box and whisker plot from question 1, and we're going to remove the outliers from that 5-number summary. So a lot of work. This stuff is already ordered in least to greatest, so we'll just get going putting this in the calculator. So let me pull up a graphing calculator. I'm going to enter my data in, which is going to do a lot of the work for me by calculating the, we can calculate mean and median and all that stuff right away, and the 5-number summary. So what I'm going to do is calculate all that stuff. I'm going to first go to stat, and then we're going to edit and put all these numbers in. So 9.7, 10.3, 10.6, 10.9, 11. I need to slide this over. Blah, 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 blah. Okay, 11.4, 12. Okay, so a total of 12 data points are going into the calculator. And right away, I'll just calculate all my statistics right from this. I'm going to hit stat and go over to calc, and we are going to calculate the one variable statistics. It defaults to L1, so I'm going to keep hitting enter, and there is all of our statistical information. It calculates the mean for us, the standard deviation, which is going to talk about the spread of the data and how far apart each data value is on average from the mean. And then notice there's the 5-number summary right here. So I'm going to go on to the next slide where I have a number line laid out, and what we're going to do is first do a dot plot right here. So I'm going to find each of these numbers and just put an X over the top of them on the number line here. So 9.7 would be somewhere right here. 10.3, 10.6, 10.9, 11. A couple of these 11 twos. So the dot plot is not the most accurate thing to have, but we can still see that there is a cluster of numbers on here, and then slowly trickles off to the right where that 16 is way over there. And what that's going to do is skew the data a little bit. If that 16 was not a part of that, it looks like this could be a symmetric data plot. But since that 16 is part of our data, that's really going to drive the mean closer to the right-hand side. So we'll take a look at that. So basically that's the entire dot plot, just organizing the numbers by finding them on a number line. The histogram, I'm starting with values, or starting with the value of 9 for whatever this data represents. But once we hit 10.5, it slides right into the next bin. And once you hit a data point of 12, it'll be a part of the next bin. And we're going to calculate the left-hand side, which is the frequency. So it's talking about how many numbers are in each of those. So for example, if I were to show where these marks are on my on my dot plot, I can find where 10.5 is, and it looks like I have a couple numbers in my first bin. And I'm going to find where 12 is, but remember that once you have a data plot of 12, it becomes part of the next bin. So these are my separate divisions. There's 13.5, here's 15, and then 16. So I'm going to have 5 bins, and we'll just calculate the frequencies of each of these. So notice 2 numbers are in this first bin. So I'm going to draw an arrow going over to 2. Okay, and then I'm going to count all these values. 1, 2, 3, 4, 5, 6 values are in there. So I'm going to go all the way up on my frequency to 6, which looks like it's going to be our largest bin. The next bin, since like I said, if 12 is the number on the bin and we do have a data point that is 12, it moves into this next bin with a frequency of 3. If you notice that there are no numbers between 13.5 leading up to, but not including 15. So this is going to be an empty bin. Sad day. But then there's this one last data point over here between 15 and 16.5. So I'm going to move a bin with a frequency of 1. Again, what that's going to do is skew our data. It looks like I can make kind of a little slope here going all the way to the right. And same thing on this graph where there's a big peak or a cluster of data points on the left-hand side. But what this value is going to do out here is drive up my average. It won't change your middle number. I don't care if this last number was 100. It's not going to change what's in the middle of all these numbers. But if you were to add up all these numbers and then divide by how many you have, which is how we calculate mean, it would drastically change. The last thing, I'm going to take down my 5-number summary, which was on here before. So I have a minimum of 9.7. My maximum is 16, and then the 3 numbers in the middle. So 10.75 and 12.2. 75. Q3 is 11 or 12.2. I have my median was in the middle. It was 11.2. We had a minimum value of 9.7 and a maximum value of 16. And those 5 values are what we call the 5-number summary. And that's what helps us build our box and whisker plot. So I'm going to find where these 5 numbers are on my box and whisker plot on my number line down here. And I'm going to mark off 9.7 is here, 10.75, 11.2, 12.2, and then all the way over to 16. Holy cow, that's way over there. And it's just another indication that this data is skewed since one of your whiskers is significantly longer than the other. So the data, again, looks like it is skewed right because the data is piled up on the left side. Speaking of percentages, we would have basically from here, here, and here where my cursor is. So this entire first chunk of data between your minimum and your third quartile, that makes up for 75% of your data. So 25% is in this huge whisker. So that means that the data is, again, skewed to the right. The mean, when we calculated, if you do look at the calculator, if I were to go all the way back to the top of all these statistics, the mean is up here with 11.65. So that's the X bar. So if we look at that, our median is at 11.2. The mean is going to be to the right of the median. And again, the reason for that is because our data is skewed to the right. So if I were to ask what's the better measure of central tendency right now, you would want to answer as saying the median, because that's where the majority of your data lies. It's a more accurate number because your data is clustered or peaked to the left side. And again, what this value of 16 is going to do is drive up this mean. This 11.65 is really affected by the value of 16. So we'll take a look at what our data might even look like without that value. So moving on to the next thing, our next task was to calculate the mean and the IQR. So I'm going to do that on this next slide. Again, your mean, you would add up all these numbers and divide by how many you have. But again, X bar on your calculator, it does it for you. You had a mean of 11.65. In order to calculate the interquartile range, the IQR, we're going to take our third quartile minus the first quartile. So this is where 50% of your data is going to lie between these two numbers. So our third quartile was 12.2, and the first quartile was 10.75. So if you take 12.2 minus 10.75, we're going to get an IQR of 1.45. So that is the interquartile range. It is the distance from your first quartile to your third quartile. And we are going to use that then to identify what our upper and lower fence is. So I'm going to do that next, and I'll kind of make a divider here. So the first thing, in order to calculate upper and lower fence, we are going to take the IQR and we are going to multiply it by 1.5. So the person that made the box and whisker plot way back in the day figured out that in order to determine what outliers are, we need to first figure out past your third quartile and before your first quartile how extreme a value would have to be in order to be an outlier, and that's why we multiply by this 1.45, or I'm sorry, by the 1.5. So if you multiply that out, you get 2.175, and this is the value that's going to help us calculate our upper and lower fence. So lower fence, and then upper fence, and what we're going to do is take, in order to calculate the lower fence, we're going to take Q1 and we are going to subtract this 2.175 value. And in order to calculate the upper fence, we're going to take Q3 and we're going to add the 2.175. So let me just fill in a couple numbers here. Q1, if you were to go back in your data, um, Q1 was the 12.2, or I'm sorry, the Q1 is the 10.75. So we're going to take 10.75 and minus 2.175. So a little subtraction, 10.75 minus 2.175 gives you a lower fence of 8.575. And then if I want to calculate my upper fence, we're going to take the 12.2, which was quartile 3, and we're going to add that 2.175 that we had gotten to earlier. So 12.2 plus 2.175 gives me an upper fence of 14.375. So what this means, if any value on this entire data set is below 8.575, it would be considered an outlier for the lower end of your data. If you were to have a value that would be greater than 14.375, it would be an outlier for the higher end, which if we notice, the value of 16 is greater than 14.375. So I'm going to write it down at the bottom here. 16 is an outlier. So now what I'm going to do is we're going to recalculate our mean. So I'm going to go back and bring up my graphing calculator. And we're going to recalculate what our mean would be if we remove that one data point. So I'm going to go back to Stat and Edit. And I'm going to scroll all the way down to where I find 16. Oops. And you're going to go put your cursor over to where 16 is. And I'm going to hit Delete. And now I'm going to go back to Stat and over to Calculate. And we're going to calculate our one variable statistics again. And notice that our mean goes to 11.25. So I'm going to write that down. I'm actually going to go on the next slide. Our mean x bar becomes 11.25. So the mean before was 11.65. So if you remove that outlier, your average is going to go down because that value of 16 was really bringing up the mean so much. So 11.25 is our new mean if we subtract it out. And now I'm going to make my modified box and whisker plot. 9, 10, 11, 12... 13, 14, 15, 16. Okay, so now that our number line is updated, I'm going to identify where my outlier was, which was the value of 16. So on the number line, we are going to put an asterisk over where that outlier is. And then we need to move my whisker, the upper end of the whisker, to the next highest data point. So my next whisker would be over at 13.1. Everything else would stay the same though. Your lowest value is still 9.7 because that was not below your lower fence. Your quartile 1 was at 10.75. The median is at 11.2. And then Q3 would have been at 12.2. So removing that outlier not only shifted the mean lower because it went from 11.7 to 11.25, but it's also going to make your data look a lot more symmetric. So notice how your whiskers are close to the same length. Your data is pretty centralized. There's a giant cluster in the middle of the 50%. So removing that outlier is going to do a couple things. Like I said, it moves that median, or I'm sorry, it shifts the mean down closer to the median, and it makes your data more symmetric. But you still have to identify where the outlier is on the number line.